Section 3.3, Part 1. Here we go. Solving linear equations in 3 variables. The first thing we actually want to look at is we have here in example 1 a system of equations that has 3 variables in it. So if we have 3 variables, we have to have 3 equations to be able to solve it. But in example 1 they say, is the ordered triple 1, negative 3, 0 a solution to the following system of equations? So we're not actually solving this, we're going to check and see basically if 1, negative 3, 0 is an answer to this system. The way we do that is if I have an ordered triple, which is kind of like, we've been dealing with points x, y. Well, now we're adding a third thing to our point, which we call z. Okay, so we've got x, y, z. So x would be 1, y would be negative 3, z would be 0, and we're gonna solve this out. So we need to plug these in. On this first equation, negative 5 times x, which we're saying is 1, minus 2 times y, which is negative 3, plus 3 times z, which is 0. We're trying to figure out, does that equal 1? Okay, we don't know yet. We're trying to figure out if it equals 1. So we have to work this out. And you can stick this in the calculator if you want to. But we'd end up with that 3 times 0 goes away. This is negative 5 plus 6 right here, which means that we do end up with 1, which does equal 1. So the first equation checks out. It actually works to have 1, negative 3, and 0. We have to keep checking until we're either done with all the equations, and if we check all of them and it works, then it is an ordered triple, or it is a solution. If we check one and it doesn't work, then we can stop and say, well, no, this isn't a solution. So second equation, plug in x, y, and z, and we're trying to figure out if the left side is going to equal negative 9. So if I work this out, negative 3 times 1 is negative 3, 2 times negative 3, negative 6, 6 times 0 is 0, so negative 3 plus negative 6 is negative 9. Negative 9 does equal negative 9, which means the second one works. And then we have to try the third. Hopefully if one works out to not be a solution, hopefully it does that pretty early on, because then that's less work we have to do. But if it is a solution, we have to check all 3 equations to see. Trying to see if this equals 8. So 2 times 1 is 2, negative 2 times negative 3 is positive 6, 2 plus 6 does equal 8. So the third one worked, and so our answer to this would be that it is a solution. Alright, so here's where the fun begins. We are trying to solve this system. It says by elimination. That's the way we're going to start off solving it for x, y, and z. Excuse me. And so what we want to do is we want to take 2 of our equations and try to eliminate a variable. So if I look at this, like if I look at my first 2 equations here, if I add those equations together, which is what we do when we do elimination, my y's will cancel out. Okay, so I'm going to write those 2 equations so that we can show that we're canceling those out. Okay, we're going to eliminate, so we cross out our y's. We have negative 7x plus 1x, which is negative 6x, 4z minus 3z, which is 1z, haha, 1z, and negative 29 plus negative 5, which is negative 34. Okay, now what we want to do is we have an equation with x and z. We need to be able to find x or z. We need another equation that has x or z. So we can use one of the equations we started off with, but we also have to use this third equation now. So I would say if we use the second and third equation, what the key thing is here is that we have to eliminate our y's again, because if we try to eliminate something else, we haven't actually helped ourselves out at all. We need to re-eliminate the y's using a different set of equations. So looking at the second and third equation, again, I'm set up like I don't need to multiply by anything. I can just go ahead and eliminate. So x plus 5x is 6x, because that's like 1x. The y's canceled. Negative 3 minus 5 is negative 8. Negative 5 plus 25 is 20. And so now I have two equations here on the left and the right that both have x's and z's. And so what I can do is I can put those together, like I can move the one on the right underneath this one on the left, and now I can say, okay, now let's eliminate x or z. And in this case, it'd be easiest for us to eliminate the x's. It's already set up to eliminate right here. So 1z minus 8z is negative 7z. Negative 34 plus 20 is negative 14. And so I would divide by negative 7 on both sides. And I get that z equals 2. So z equals 2, I need to go back and find x and y, so I'm going to have to kind of reverse plug in. If I know z equals 2, I have to plug in to one of these two equations, which one of those is that one as well. Like somewhere where I have two variables, I have to plug in that z equals 2. So let's just plug it into this one right here. 6x minus 8 times 2 equals 20. So 6x minus 16 equals 20. Add 16 to both sides. You get 6x equals 36. Divide by 6. X equals 6. So now I know x and z. Well, I've got one more thing to do. I need to plug in z and x into one of my original equations up here so that I can figure out what y is. I'm going to pick the second one just because it has overall the smallest numbers. So 6 minus y minus 3 times z, which is 2, equals negative 5. So up here I have a 6. I have negative 3 times 2, which is negative 6. So if I do 6 minus 6, those cancel each other out. So I really have negative y equals negative 5, and so you divide both sides by a negative 1, and we'd get that y equals a positive 5. So our answer is that x equals 6, y equals 5, z equals 2. So there we go. Example 3. So we're just going to basically have to practice this until we get used to it. If I look here at example 3, it's not quite so easy to see what maybe we should go with, because keep in mind we're going to have to eliminate the same variable twice using these three equations. So like our y's, if we look here, our y's look like a good case, except that if I start trying to eliminate my y's again, that's not going to be quite as pleasant. Same thing with my z's. I can probably eliminate my z's pretty easily here, but here that's going to be a little more difficult. If we look at our x's though, I know that to eliminate the x's here, I could multiply the second equation by a negative 4. To eliminate the x's here, I can multiply the second equation by 2. So that's what I'm going to go with, is just eliminating my x's. You could eliminate y's or z's, I just feel like it'd take a little bit more work for us. So we're going to start off with these first two equations, and we're going to eliminate the x's, which means I need to multiply this equation down here by a negative 4. So I'm going to write out the first equation, 4x minus 5y plus 3z equals 5. That one stays the way it was. And now we're distributing a negative 4 through our second equation. So negative 4x minus 20y minus 12z equals negative 4 times 0 is 0. Now let's add those equations together. So negative 5y minus 20y is negative 25y. 3z minus 12z is negative 9z. 5 plus 0 is 5. Now I've got an equation where I've eliminated my x's. Now let's do it again. We could use the first and the third equation, or we can use the second and third, and either one of those is about the same in difficulty. I'm going to use the second and third. And I know that on the second equation, I'm going to have to multiply by a 2 in order to eliminate my x's. So I'm going to write the third equation down, because that's the one I'm not changing. Negative 2x minus 4y minus 5z equals negative 7. Now when I distribute the 2 through the second equation there, I have 2x plus 10y plus 6z equals 0. So my x's cancel again, which is what I wanted. Negative 4y plus 10y is 6y. Negative 5z plus 6z is 1z. And negative 7 plus 0 is negative 7. So I need to look at these two equations here and say, how would I go about eliminating? I feel like our y's would be a bad choice. It would be difficult to get the same number in front of both of our y's. But I can take this equation and multiply it by a 9, and then I'll be able to eliminate my z's. So distribute that 9 through. That gives us 54y plus 9z equals negative 63. So our 9z and our negative 9z cancel out. Negative 25y plus 54y is 29y, I think. 5 minus 63 is negative 58, and divide, which gives us y equals negative 2. So that's our first one. From here, it's all downhill. We can make it after this point. Y equals negative 2. I need to plug that back into any of these three equations up here that just have y's and z's. And I'm going to pick this one right here because it has the smallest numbers. So 6 times negative 2 plus 1z, which is just z. I don't really need the 1 in front of that. 6 times negative 2 is negative 12. And then add your 12 to both sides. And z equals 5. Now take y and z and plug it back into one of our original three equations. It doesn't really matter which one we pick. So I'm going to pick the first one. Why not? So 4x minus 5 times y, which is negative 2, plus 3 times 5, which is z, equals 5. So I need to do negative 5 times negative 2 is a positive 10. 3 times 5 is 15. If you add those together, you get 25. So 4x plus 25 equals 5, minus 25 on both sides. Divide by 4. So x equals negative 5. So that means our answer here would be x, which is negative 5, y, which is negative 2, z, which is positive 5. Again, a bunch of this has to do with just practicing. The more you practice, the easier it'll be, which is why we're doing as many examples we are. But this example also ends up being a little tricky, and so I just want you to see what to do if this happens to you while you're eliminating. So on here, to me, if I look at my y's, since I have a negative y, a positive y, and a negative y, I can really easily eliminate the y's. So that's what I look at whenever I see this. The x's and the z's on this, I mean the z's especially, would be just as easy to eliminate, but I'm going to eliminate the y's. I think that's the way to go here. The z's would be fine too, though. And so here's what happens whenever I take these first two equations and I start to eliminate my y's. I start to eliminate, my y's go away. Oh wait, my z's go away too. That's okay. Negative 2x minus 1x over here gives us 1x. 7 plus a negative 11 is negative 4. Wow, we just really quickly got that x equals negative 4. That was kind of fantastic. Well, what we're going to have to do is we're going to have to go back to our original equations and we're going to have to eliminate again. And so if I look back up here, let's use the second and third equation, for example, and we can eliminate the y's again. The important thing is that we want to try to have x in the equation, but actually this one works out even more nicely. So when I go to eliminate here, my x's cancel, my y's cancel. 60 plus 60 is 12z. Negative 11 minus 25 is negative 36. So you divide by 12 and z equals negative 3. So, I mean, that really quickly got us two of our answers. That's kind of like a best case scenario. It could have ended up that on our second one that we would have just eliminated the y and had x and z, and we'd have to plug in the x to find z. That's more likely to happen on your homework than what just happened here. We need to plug these back into our original equations to find y. So I'm going to pick the first one just for fun. 2 times negative 4 minus y minus 6 times z, which is negative 3, equals 7. This would be negative 8. This would be plus 18. And together, negative 8 plus 18 is 10. So negative y plus 10 equals 7. Subtract the 10. Negative y equals negative 3. So if I divide by negative 1 to get rid of that negative on my y, I get y equals 3. So it actually worked out well that we eliminated more than one thing. That's kind of a little bit of a shorter problem because of that. But that can happen sometimes. Don't freak out if that happens to you.